Yeah, very well said. And you've actually partnered with Andrew Ng's deep learning AI
Yeah,
to deliver a course on semantic search and large language models
yeah,
that is based on these embeddings and how important they are. And that's something I end up talking about them a fair bit on air because that's something that at my company in Nebula that I co-founded, embeddings are the key to our intellectual property as well.
yeah.
So that course on semantic search and LLMs that you did with your Cohere colleague Jay Alamar,
Jay, a great
yeah,
educator.
maybe, yeah, as well. So let's talk a bit about semantic search more. Let's dive into
Sure.
embeddings more. So how would you describe embeddings and say, how semantic search differs from a traditional keyword search?
Yeah. Great question. So to me, embeddings are the most important objects in LLMs, and I would go as far as saying in many fields in machine learning is the most important object because it's really where the rubber meets the road, right? Like it's where we translate our language to computer language. Computer language is numbers and only numbers. And so if we're working with embeddings, we need an image embedding that turns into numbers. If we're working with text, we need a text embedding that turns text into numbers or sounds into numbers or anything we want, we need an embedding. And if that embedding is not super strong, like you're not doing anything, right? So the better embeddings get, the better LLMs get. If somebody comes up with a better embedding tomorrow, believe me, all the models are better because it's just a better way to turn text into numbers. So some problems that were hard 10 years ago, like classification, now are much easier because embeddings are better. And what's an embedding? An embedding is just you're literally associating your text or your words to a bunch of numbers. So a vector, like a list of numbers. I like to see them graphically. So I like to imagine, I always bring everything down to the simplest example. So I like to see sending words to pairs of numbers. And what's a pair of numbers? It's a coordinate in a plane. And so I imagine all the words flying around, and words that are similar get put close. So if I have an apple and a pear, they get sent to similar pairs of numbers, which is a similar location. And I also like to think as each coordinate as a description of the word. So in a very toyish example, I could think of the first one as the size and the second one as the flavor or something like that. But if you have thousands of numbers, then you're pretty much describing your sentence or your word or your piece of text in a very, very, very detailed way using a lot of numbers. And maybe these numbers mean something to us. Maybe they don't. Maybe they mean something to the computer. But it's really that. And then one of the things that embeddings are really useful for is semantic search. When we search, for example, if I'm going to search for uh, I always use this example that let's say you search for visa to travel from Brazil to USA, and I want to find the and I want to find the article that has as many words as possible in common with those, and I find one that says visas to travel from USA to Brazil. It's the complete opposite. It doesn't help me at all because it's flying in the wrong direction. But it matched all the words. So that's keyword search. If I find the documents that match all my words or as many as my words, it's decent, but it doesn't get you there because I could reorganize the words and change the meaning of sentences. That's when we use semantic search. So in these embeddings, you're locating sentences in a plane or in space. And if I have all my documents and they're flying around and I send the question to my embedding, then it's very likely that the answer is going to be close. So if I have so embeddings are just a way of mapping of putting all the text in flying in space, and then it's easy to search in that space instead and find an answer. So we've seen a lot of improvement with semantic search versus keyword search. And then when you throw in things like re-rank, for example, is very useful because see that the closest sentence to something is not the answer, right? If you ask me a question, you ask me what color is an apple, and I answer to you, what color is an orange? Then you say, well, what the hell? And I say, well, I just gave you the closest sentence, but it's not the answer, right? So re-rank helps you actually locate the answer with an extra training. But yeah, semantics is in a great place. I've seen some great results. So yeah, I've been happy to see that.
Very nice. So I'll try to repeat back to you some of what you said. So embeddings are they allow us to have a language of computing
Mhm.
where we speak in, say, natural language or math or code. So we represent things in that kind of form. When we want a machine to be able to do something helpful for us with that language, we need to convert it into some kind of numeric format.
Mhm.
And I love that idea of, explaining the kind of the simplest embedding would probably have just two numbers, two float values that you represent some word or some sentence or some document by, and then you can very easily imagine that in a two-dimensional space.
Yep.
If you all of a sudden have three dimensions, three numbers that you're using to describe the location of that word or document or piece of code or whatever it is, however you're embedding that, if you go from two to three, then it's like imagining it in the visual world that we encompass in a 3D
Exactly.
space. And then it becomes hard for us to visualize in four or more dimensions, but for a machine to be able to represent this is trivial. The
Yep.
math is all the same, the linear algebra is the same. And so uh, it's very common with organizations like Cohere to have your embeddings have thousands of dimensions. And as you're saying, that then allows a huge amount of granularity for semantic search. So we can embed any natural language code, math, whatever it is that we want to represent. It can be understood, its meaning can be understood well in this high dimensional numeric space that the machine has, and that allows it to fulfill lots of different kinds of things. So you mentioned earlier clustering, um, but I think one of the most interesting applications that we see today with generative AI is things like being able to answer your questions. And so by by using this semantic search, you can get into the right region based on the person's query, like you said, what color is an apple or something like that.
Mhm.
That can bring you to some region of that high dimensional, those many thousands of dimensions of space where everything's about the color of fruits. But
Mhm.
then once we get to that space, re-rank allows us to find a great answer to the question as opposed
Yeah.
to just some phrase related to the question.
Exactly. Yeah. Very well put.
Nice, awesome. So that helps us understand embeddings and yeah, and Cohere's business model, how they're helping out the enterprise by ensuring that they have great embeddings, facilitating all kinds of these enterprise capabilities. So, what kind of experience, if I'm a user of an application that is powered by Cohere embeddings versus maybe some old or poorly trained embeddings, maybe some embeddings that I tried to make myself that weren't well made? As a user, how can my user experience? Are you able to give some examples of how my user experience will be improved by better embeddings? I guess one we already talked about is question answering.
Mhm. Yeah, I mean, everything becomes easier. The analogy I used to say, imagine if you had a great book, but a really awful translation. So you can only enjoy it so much, right? Like you can only understand so much. And so a good embedding just translates your data really well into numbers. So, for example, 10 years ago, let's say we had embeddings that were so-so, or even no embeddings. Like you can just use every coordinate as a different word, and you would have a huge space. But anyway, the fact is, let's say we have poor embeddings 10 years ago, and you want to do a classification model that tells you, I don't know, if emails are spam or not. But the region between the spam emails and the non-spam emails is very, very complex. Like it's very curvy. In order to separate them well, you have to use a really big neural network to come up with a really complicated boundary. There may be problems overfitting, etc. Let's say you have an amazing embedding that picks up things so well that puts all the spam emails on one side and all the non-spam emails on the other side, and it's really a line that cuts them or a plane. I'm exaggerating.
Mm,
I'm
mhm,
exaggerating.
mhm, mhm.
But a good embedding makes these problems easier. So you can now, I've done classification problems with like 3 or 4 examples. So you can do much better now as opposed to before that I needed thousands of examples, a huge model. So that's just classification. But for example, clustering is the same thing, right? Like if I have a really good embedding, the clustering becomes much easier because things are located in the right place, right? So the embedding is the most fundamental thing, and many companies just want the embedding, right? Like many the tools, they're like, okay, we have a bunch of machine learning stuff. I just want your embedding, and I can do wonders with it.